Hello, we are discussing about GATE 2014 ECE paper, and it has given that one a series LCR circuit, that is series RLC circuit, is operating at a frequency other than resonant frequency. It is operating at a frequency which is not the resonant frequency, and the operating frequency is such that the current leads the supply voltage. At that operating frequency, current leads the supply voltage, and magnitude of current is half of the value at its resonance value. If the values of RLC are given as 1 and 1 and 1, then what is the operating angular frequency? We are going to find what is the omega value, operating frequency. Okay, so this is a simple RLC circuit, series RLC circuit, where V is the voltage applied for that one. Okay, and assume that one current flowing through this is I of omega at any frequency. Okay, omega is nothing but angular frequency, so we are going to find omega value. Okay, I of omega can be written as V by R plus, okay, J times of V by R plus. Instead of J, I will write that directly R plus total resistance, that is resistance of R, reactance of L, reactance of C. So reactance of L is XL and reactance of C is XC, where it has given V by R plus J omega L plus 1 by J omega C, which you can write it as V by R plus J omega L minus J 1 by omega C. 1 by J is minus J, so you can write as minus J into 1 by omega C. But this is general formula for the I of omega. It has given that at operating frequency, let us assume at omega is equal to omega 1 is the operating frequency. Okay, so let omega 1 is the operating frequency of the circuit, and omega R is the resonant frequency. So at omega is equal to omega 1, it has given that one current leads voltage. Current leads voltage means the circuit is capacitive. The response of the circuit is, that is circuit becomes, response of the circuit is capacitive. Okay, because in capacitor current leads voltage, so capacitive, that means XC is going to be greater than XL. So I of omega 1, I at omega is equal to omega 1, I am going to write this equation R minus J omega C, 1 by omega C minus omega L, because omega 1 by omega C is greater compared to omega L, and this is negative, so that you are going to get as minus J. So this equation I am writing for at omega is equal to omega 1. Okay, and this value is going to be the equation 1. Okay, and at resonance it has given that one. Okay, at resonance circuit is resistive only, because XL is equal to XC. By that time you don't get this term. Okay, so omega L is equal to 1 by omega C, so that no reactive terms are going to be present, only circuit is going to be having a resistance R. So that I at resonance, I at omega is equal to omega R is V by R, and it has given I at omega is equal to omega 1 is half of resonance. So half of resonance is nothing but I at omega is equal to omega R, by 2, which is nothing but you can write it as V by 2R. V by R minus J times of 1 by omega 1C minus omega 1L is equal to V by 2R. V get cancels, and substitute the values of RLC and simplify the expression. So if you are substituting the RLC values, 1 by 1 minus j times of 1 by omega 1 minus omega 1 is equal to, okay, 1 by 2 you will get. So from this one you can write it as 2 is equal to, okay, square root of magnitude of this one. I am writing it as 1 square plus 1 square is 1 only, plus 1 by omega 1 minus omega 1 square. Take square on both sides. Take square on both sides. So this will be equal to 4 is equal to 1 plus omega 1 by omega 1 minus omega 1 square. So that is 1 by omega 1 minus omega 1 whole square is equal to 3. So you can write it as 1 by omega 1 minus omega 1 is equal to root 3. Okay, and this, if you are writing, this will become 1 minus omega 1 square divided by omega 1. That omega 1, if it is coming, it is root 3 omega 1. So you can write it as omega 1 square, okay, plus root 3 omega 1 minus 1 is equal to 0. So this is going to be looks like ax square plus bx plus c algebraic equation, and roots of this one is nothing but x is equal to minus b plus or minus square root of b square minus 4ac by 2a, that we know. So we are going to calculate omega 1 is equal to minus b, that is minus root 3 plus or minus b square b minus 4ac, that is plus 4 you will get, minus 4a, c is minus 1, so minus into minus you will get plus, so 3 plus 4 divided by 2. So this will be omega 1, okay, minus root 3, and you have to take only positive sign. Omega 1 cannot be negative. Since omega 1 cannot be negative, you must take it as positive. Positive is nothing but root 3 plus root 7 divided by 2. So finally you are going to get it as omega 1 is equal to 0.457 radians per second. Okay, so the right answer for this question is omega is equal to 0.457 radians per second. Thank you.